The 10 megaton January 15th eruption of Hunga Tonga sent ash and debris 24 miles into the stratosphere, and very well may be one of the top three largest eruptions since the VEI 7, the Tambora eruption in 1815. Absolutely mind-blowing. And you can see here the island on the left a month ago, and the remaining island as of yesterday. Just two tiny parts. The entire island is missing. Well, and at a 10 megaton blast, it's anyone's guess where it went. But the Pinatubo eruption back in 1991 was VEI 5.6, right on the cusp here. And the Mount St. Helens eruption was VEI 4.5. And this explosion was just a shy under Pinatubo. Just a sliver. And at the end of this podcast, you'll know why. Now, the first image is coming from Tonga. That's not what we want to look at.
Welcome to Mountain Dealership.
Excuse me,
Yeah, I apologize for that. So the first images from Tonga are showing heavy ash fall on the island. There's the before and after shot. Everything's covered in ash. But the event is over, and that's good news. And an event like this probably won't happen for another 1,000 years, but a significant event nonetheless. In fact, the shockwave alone was record-breaking. And the SO, here's the sulfur dioxide plume, as of yesterday, almost covering a large portion of northeastern Australia there, where the heaviest concentrations are. So that is going to be a problem for Australia for the next day or so. And waves from the eruption in Tonga also caused an oil spill in Peru, part of the small tsunami that killed one person in Peru, also causing an oil spill there. And the destruction is going to last for a while. Now, estimates are now claiming that the measurements of the cloud went up to 39 kilometers, the official estimates. And as of yesterday, we knew that it was definitely in the stratosphere because we had numbers at 30 kilometers or about, 16 miles. But this is confirmed to be at 24 miles, potentially, pre-confirmed. And NASA scientists estimate the Tonga blast at 10 megatons. And that blast was felt around the world. And you can see here the propagating wave as it moved further and further away as it hit the instruments. Just an absolutely one of the most spectacular geologic events on Earth in all of modern human history. Simply because it produced a tsunami, there is not a volcanic eruption in human history that we know of in recent human history that caused a Pacific-wide tsunami. That is absolutely spectacular, first of all, the power of this one single vent in Tonga. And the height of the plume, over 33 kilometers here in the initial aerosol extinction values here that were received on the 16th, now being risen by 3 kilometers. That's not unimaginable. And the SO2 concentrations now still being crunched. Here we can see that volcanic plume, at least from the Calypso orbit, at least 33 kilometers, well above the troposphere-stratosphere boundary. So these aerosols are going to maintain and last for years. And what happens when aerosols last for years is the planet cools. Now, the atmospheric impact of the 1991 Mount Pinatubo eruption was quite significant. In fact, it cooled the planet 0.5 to 0.6 degrees in the northern hemisphere, equivalent to a hemispheric-wide reduction in net radiation of 4 watts per square meter, and a cooling of perhaps as large as 0.4 C over large parts of the entire Earth from 1992 to 1993. Now, some climate models seem to have predicted the cooling with a reasonable degree of accuracy. So what we should expect is cooling from this eruption. Now let's compare it to other major eruptions like Mount St. Helens, which never reached it to the stratosphere, never reached the stratosphere. Yet it's still a VEI 4.5. It only reached 20 to 27 kilometers above the sea. But this one, quite different. And the Tambora stratovolcano, the largest eruption we know about, VEI 7, reached 40 to 50 kilometers in altitude and cooled the Earth significantly. Here's the Tambora cool down, a full 1.5 C, up to 1.5 C for 3 years. 18, 15, 16, 17, 18, Chile. And then the Casaguina stratospheric injection caused cooling. Krakatoa, say it ain't so, caused cooling. Agum, Chicon, and the Pinatubo 91 eruption caused spectacular cooling, almost a half a degree C, like we said, for 3 years. And that's because the stratospheric injection of aerosols causes the cooling. And you need to get above that boundary to cause the cooling. And here are some of the historic volcanoes that cause cooling. Here are the solar cycles associated with them. You can see that they happen every solar cycle or so. And there was a lull there between 20 and 60. But again, global surface temperature and their related stratospheric aerosol injections, the 1960 whatever eruption of Agung, 65 or so, caused major cooling. The El Chacun, cooling. Mount Pinatubo, cooling. And if we go back in time, Okatiana, major cooling. Krakatoa, major cooling for long periods of time. Asya, cooling. Shivalush, major cooling period. So what we know is that all volcanoes that stratospherically inject significant stuff cool the Earth. And this one, well, this one is one of the top 3. So what we should expect now as we crunch the data from Hunga Tonga is a cooling of at least, I would say, up to 0.3 C. Not a year without a summer, but maybe a cooling in some places. And if we have another eruption, it could add insult to injury. These are all single events causing half a degree shifts or so. And the Hunga Tonga Haipai volcano, albeit not a lot of, they're claiming it's just a half a megaton of SO2, but that was an initial estimate. So we're waiting for some official numbers from what's actually happening. But we do have wonderful estimates on the aerosol extinction values, the height, and the plume emplacement from multiple telemetries. And those numbers will get better, and we'll have official numbers when we get them. Just like we officially know that every single volcano that has a stratospheric injection causes cooling. So who is anyone fooling? This is one of the highest eruptions and the largest shock wave since Mount Tambora. And Tonga's volcanic eruption may also harm the environment for years to come. We're talking, it may disrupt fisheries, long-term damage to coral reefs, erode coastlines. There's not a lot of, people are saying, where is all the magma? It blew up into almost space, for goodness sakes. A lot of it's floating around in the stratosphere. And there's not a lot of land around this area. There's miles of ocean before you even get to the first island in Tonga. And that's good news for the people that live there, because if you were anywhere near here, you would have been buried in ash, burned to death, or your eardrums would have exploded. And this volcanic eruption is going to be officially listed as VEI 5. Period. That's boom. I hope you got something out of the video. Very significant eruption we all just lived through. There's only been 3 casualties in the Tonga Islands that I know about, and that is amazing. But based on all the science we know, and the fact that this may have reached 24.2 miles into the stratosphere with a significant injection, this will 100% cause cooling on Earth. I don't care what anyone suspicious of me says. And that's a boom. Subscribe to the channel. Share this with like-minded people. And stick with the winners who use data and information to give you the facts.